This is January 2016, paper 1. This is question 11. A student investigates the extension of elastic band for different forces. What equipment would we need for this investigation? Well, you could say you needed a clamp stand, because you've got to put something to put the elastic band on. What else we need? Well, we need a ruler, something to measure the extension with, and we need weights. So those are the three that we would need. So then if you look at these are the type of variables, and these are the variables, and this is a type of variable. So the extension is one that we're going to measure. So that should be our dependent variable. The force is what we're going to change. So that's our independent. And the temperature should always remain the same. So that's our control. Describe how the student can measure the extension of the elastic band when he adds a force of 10 newtons. Well, it's 2 marks, so you just have to describe it. Measure the length without weight. Put the weight on. And then measure it. Subtract those measurements. Very simple, 2 marks. Subtract those measurements. He plots the loading data on a graph as shown. So he's got, what he does is he loads it with weights, measures their extension, then as he's taking those weights off, measures the extension again. So you can see that it doesn't quite go back. Oh, actually, no. It goes 2, 4, 6, 8, 10. So here it goes 0, 1, 3, 7, 9, 10. So suggest how we can improve the quality of this data. Well, surely you would do it at the same intervals. Same intervals for loading and unloading. What's the point in loading it and then unloading it with a different weight? So these should match. So match the intervals for loading and unloading. And then you could also, this one goes 3 to 7. So you could fill in the gap. Fill in the large gap for the unloading data. You could get more readings. So it's starting, you'll see later, but that it starts to curve. You can get more readings out of these as well. Maybe you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, rather up in 2s. And increase the range of loads. Right. Draw a curve of best fit through the loading data. This is going to be hard for me to do, but I'll give it a go. So we want to go up through here. And then through there. We missed that top one, unfortunately, but you shouldn't. So it should be something a bit more like that. So we want to, it's a curve. So you can see that it's almost a straight line here, but it curves down here and curves up here. I think what people are going to do is just try and draw one curve through it. That's not going to work. So this one was showing that it was curved in 2 places, and that's absolutely fine. On the same axis, you would plot these. So I'm not going to plot those here, but you can plot them. And then you draw the same sort of curve of best fit going through them. They're going to check that you've got the plots in the right places first, so be very careful. The best thing I could say is, if you wanted to do 1 and 1.4, so I'm going to go to 1, and then I'm going to count to 1.4 first. So these go up in, this is 0.2. So it's about there. It's hard to do it with my pen though. And then I would keep putting those on. Be very careful about how you're reading those, because plotting those on is 2 marks just for putting some crosses on. Drawing that line of best fit again. And then the student concludes that the band is an elastic material and it obeys Hooke's law. Discuss whether his conclusion is correct. So it's just a discussion, but it's 3 marks. So they're looking for 3 different points. So you could say that Hooke's law, it doesn't obey Hooke's law because the graph is not linear throughout. Hooke's law should be directly proportional. So when there is no force, there is no extension. And as you add on extension, you get this exactly the same extension as you add on force, you get exactly the same extension each time. So Hooke's law requires extension to be directly proportional to the force. It does show elastic behavior though, because it does go back to 0. It does go back to no extension as you unload it. So it does show that it has elastic behavior because it returns to its original length. You can also have some data points out of here in order to back up your argument. But stating the Hooke's law and describing the difference between Hooke's law and these graphs, that's what's going to get you those